complex numbers, looking at graphs and roots. Now, this is just a bit of an introduction. This is on page 12. I just wanted to comment on something that you may have noticed earlier. When we were solving the quadratic equations, let's say we go back to example 15, you'll notice that we got minus 1 plus or minus root 7i over 4 as our solutions, and you'll realise that from the quadratic formula, because we have a plus minus, we always get the same number but with the opposite sign in the middle, and we know that they're called conjugates. And that's true of all complex roots. They always come in what we call conjugate pairs. So if you know one of the roots, you automatically know the other one. So if I told you one of the roots was 3 plus 4i, you would immediately tell me that the other root is 3 minus 4i, because they come in conjugate pairs. So that's a good phrase to learn, conjugate pairs. Now, when you start looking at higher order polynomials, that's quadratics, but if we look at cubics, cubics tend to have 3 roots. Now, obviously 3 roots can't come in pairs. That doesn't make sense. So what can happen? Well, you might get 3 real roots. That's the sort of thing you'll have studied in C1, crosses the axis 3 times. You might actually get a repeated root. So rather than coming down and crossing, it just touches. That's called a repeated root. But you can get a situation like this where it only actually crosses once. So this would be a real root here. And then it doesn't come down and cross again. That indicates that as well as this real root, there would also be a conjugate pair that's sort of notionally represented by this part of the curve here. So for cubics, you're always going to have one real, and then you might have a conjugate pair, or the other two might be real as well. When you come to a quartic, you've got lots of different possibilities. You could have 4 real roots. So this is a graph of a quartic, and there are 4 real roots. They could be repeated. So you could have it crossing here, and then just touching there. That would still be real. You could also have 2 real roots and 1 conjugate pair. Remember, the complex roots have to come in pairs. So you could have a complex pair and then 2 real roots. Or you could have no real roots at all, in which case you'd have 2 conjugate pairs. So you'd have, say, 3 plus 4i and 3 minus 4i, and then another pair as well. So you'd have 4 complex roots in 2 conjugate pairs. So these are the sorts of things that we're going to be looking at in the next few examples. You'll be pleased to know that we don't go above power 4.